Hello, and welcome to a presentation about closing the achievement gap at University View Academy. Today we will discuss an education plan that will include a review of our achievement gaps, best practices, and recommendations for teachers to help close those achievement gaps and use the best practices to their advantage. First, let's review our achievement gaps that we have found through the gathering of data. In this slide, you can just see generally, we have testing data by ethnicity from 2016 and 2017 and 2017 and 2018 for English 2 and 3 and for mathematics. A summary of these achievement gaps is that in English 2, the gaps showed that the data is consistent for both years and clearly shows white students performing at a higher level than Black students. And for mathematics, the data shows that in algebra, there did not appear to be a gap in 2016-17, but there is a gap in 2017-2018. In geometry, there appears to be a racial gap in both years. This is the testing data for socioeconomic status, economically disadvantaged versus not in English in 2017-18, and in math for 2017-18. The data showed that students who have a higher socioeconomic status consistently score better than those with a low socioeconomic status in both English and mathematics. Here's some testing data from the 2017-18 LEAP 2025 and EOC tests for English 1 and 2 school versus state and Algebra 1 and Geometry school versus state. Our goals, after reviewing this data, is that UVA needs to improve the number of advanced scores in English 1 and 2. And in algebra, UVA is consistent pretty much with the state, but we would still like to raise our advanced scores. And geometry is going to be our biggest gap. We need to increase the number of mastery and advanced scores and drastically decrease the number of approaching basic scores. Let's talk for a second about our achievement gaps and deficiencies summed up. The first one, overall, geometry scores were lower than all other subjects. The second gap or deficiency we found is ethnic and socioeconomic gaps in achievement were found in all subjects. The third item we're going to look at is that UVA scored lower than the state average in many categories, especially in math. And the fourth item is that UVA had a low number of students scoring in the advanced categories across the board. One way to improve academic achievement is implementing best practice strategies in our classrooms. So let's talk about what best practices in our classrooms would look like. What are best practices? These are the 7 structures of best practice teaching for all subjects. Number 1, we have the gradual release of responsibility. Number 2, classroom workshop. Number 3, strategic thinking. Number 4, collaborative ideas. Number 5, integrative units. Number 6, representing to learn. And number 7 is formative reflective assessment. Let's talk about what all of these mean. The first one, gradual release of responsibility. An easy way to remember this one is show me, help me, let me, or I do it, we do it, you do it. In other words, the teacher will model what they want the students to know. You'll use scaffolding to do it with the students, work some problems together, and then you will support the students while they do it or try it on their own. What is the classroom workshop? You're going to treat each class as a workshop. A great way to do gradual release is using a classroom workshop format. The first 5 minutes approximately will be your introduction, followed by a 10-minute mini lesson. That's where the teacher is giving the information. 25 minutes you'll work together, where the teacher will be helping the students. They'll be working in groups, working with each other, and then they will do it on their own. And then the last 20 minutes you can share with the class. Strategic thinking. Strategic thinking, we have into and beyond, are our three things to remember. Into are activities to prepare students before they read, like KWL. Through, activities that help students construct, process, and question ideas as they read. For example, text codes. While they're reading, they can make little markings on the side of the text. And beyond, activities that guide the student to reflect. Example is discussions, journals, etc. Collaborative activities. If we remember that social relationships come first and the students can work with each other, that is a best practice. Integrative units include deepening content. One thing to remember, especially in the high school years, is that every student doesn't need to study the exact same things as deeply as all of the other students. So dividing things up so that students are delving into a subject that interests them or part of a subject that interests them will really help them absorb the information. And then they can watch a presentation that someone else does on something that interested them, and they'll all learn everything. Representing to learn. So it's not enough to learn, we must act on it or have the students act on it. And formative reflective assessment, observational records, student portfolios, learning exhibitions, etc. So our focus today is going to be mathematics. This is a quote from Teach Step. The Common Core mathematical practice standards are the foundation for mathematical thinking and practice for students, as well as guidance that helps teachers modify their classrooms to approach teaching in a way that develops a more advanced mathematical understanding. Think of these standards as a guide to creating a more complex and absorbing learning experience that can be applied to everyday life instead of being left in the classroom. That's a wonderful quote that sort of sums up why we have the best practices. So there are 8 Common Core State Standard best practices in mathematics that we're going to talk about. The first one, make sense of problems and persevere in solving them. Number 2, construct viable arguments and critique the reasoning of others. Number 3, reason abstractly and quantitatively. Number 4, model with mathematics. Number 5, attend to precision. Number 6, use appropriate tools strategically. Number 7, look for and make use of structure. And number 8, look for and express regularity in repeated reasoning. Let's talk about what these all mean. We're going to break them down one by one, since that's what we're focusing on today. So in mathematics, we want to make sense of problems and persevere in solving them. So in other words, students should be able to explain the meaning of a problem and actively look for ways that it can be solved. Instead of just jumping right into attempt a solution, a student needs to critically analyze the math problem, speculate about the form and the meaning of the solution, and then plan a pathway to get there. The second strategy is to construct viable arguments and critique the reasoning of others. When constructing arguments, students should consult definitions, theorems, and previously established rules. They will need to justify their conclusions by building a logical progression of claims and using examples. It's also important that they are able to distinguish correct reasoning from that which is flawed. And that's a great activity, is to have them find mistakes in other people's works, peers or other examples. Best practices in mathematics strategy number 3 is to reason abstractly and quantitatively. What this means is to make sense of quantities and their relationships when problem solving. That's an important math skill for students to possess. This involves creating coherent arguments and using symbols to represent mathematical situations. Students should be able to use the different properties of operations and objects flexibly. In other words, instead of giving them the operations and properties that they should be using for a section, they should be able to read a problem and pull out of their memory or from a list of which properties would work best with that problem. Number 4 is to model with mathematics. This brings math outside of the classroom. Students must have the skills to take what they've learned in math class and apply it to situations they encounter in everyday life. What this means will evolve as students mature and work their way towards high school graduation. So when they're younger, these can be very simplistic things. When they get older, taking the skills from what they've learned in a math class and applying it to a situation in everyday life will become much more complex. Number 5 is attend to precision. Good mathematical practice also involves the ability to communicate what one has learned. Students must be able to use mathematical definitions to clearly and accurately explain their reasoning. In addition, they should be precise about units of measure and labeling axes. This is very important because it involves writing as part of their answers to mathematical problems. They should be able to explain what they are doing. Use appropriate tools strategically is strategy number 6. When solving math problems, students will need to consider the tools they have available to them. This can range from pencil and paper to a calculator to math software or a protractor. They should be able to identify which tool would be most helpful and use it appropriately. This veers away from memorization. As we know, we all have the internet at our fingertips. So finding the best resources to help solve a problem is an important skill to learn. Best practice number 7, look for and make use of structure. Students should be able to discern patterns and structures in math. What this means varies depending upon the grade level. Elementary students, for example, should know that 4 plus 5 and 5 plus 4 mean the same thing. High school students will need to note regularity in the way things cancel out when expanding an equation, such as in algebra or geometry. Look for and express regularity in repeated reasoning. So more advanced math students should be able to recognize when calculations are repeated and be constantly looking for shortcuts. Shortcuts should be encouraged when the students know how to do them. As they work through math problems, students should continually reevaluate if they are on the right track. Check as you go. So now I'm going to show you some recommendation that I have for technology apps and programs to help us utilize the best practices in math. The first one I'm going to talk about is GeoGebra. This is an excellent online program. You can also download it as an app. It is free mathematics software for learning and teaching. It includes interactive graphics, algebra, and spreadsheet features. You can see right here I have an image of something that someone made. You can move it around, you can look through it, you can determine all sorts of things. They have a graph over here that corresponds with the object. It's for all learners and teachers from elementary school to university level. Creators and users provide free learning and teaching materials and tools to create your own. This is an open, free platform. It will run on Mac, Windows, Unix, online from browser, tablet, iPad, etc. This is an excellent program to use. I have used it with my students, and they really enjoy it. So let's talk about how this relates to our Common Core best practices. So GeoGebra helps develop Common Core mathematical practices 5 and 6. Use appropriate tools strategically is number 5, and attend to precision is number 6. In particular, GeoGebra allows students and teachers to visualize the results of varying assumptions, explore consequences, and compare predictions with data. And it forces them to communicate precisely. As the user becomes more familiar with GeoGebra, she herself becomes more precise and logical. When they're creating graphs and creating objects in GeoGebra, they have to be very specific about what they put into the formula section, and they'll notice that one little thing can change drastically what the outcome will be. So this forces people to be more precisely. to work more precisely, excuse me. Okay, so that's number one, GeoGebra. I urge you to check it out, and this is the link right here if you would like to click. Realworldmath.org. This is the next one that I would like to talk about. It is related to Google Earth. This is an excellent program. Real World Math is a collection of free math activities for Google Earth designed for students and educators. Mathematics is much more than a set of problems in a textbook. If the virtual world of Google Earth, concepts and challenges can be presented in a meaningful way that portray the usefulness of ideas. This is great with bringing math into the real world. Literally, you are using Google Earth, which is showing you parts of the actual world, and math lessons based on determining things that are actually happening in the real world rather than lines on a piece of paper. This is the link right here. So which Common Core mathematical practice will it help with? The one that it will help with the most is practice number 4, Model with Mathematics. This website brings math outside of the classroom. Students will be able to take the skills they've learned in math class and apply them to situations they encounter in everyday life. Again, this is the website, realworldmath.org. Feel free to go and visit it and ask me questions as needed. It's an excellent website. There are plenty of lessons already created and you can create your own and share with others. You can do the same thing in GeoGebra. Okay, and the third recommendation I have for you today is MathSpace. So MathSpace does cost. So this is a program that if we're interested in doing it, we would be purchasing it for the school. But it's an award-winning online math program with, and this is a quote from MathSpace, adaptive learning technology that replicates the benefits of a one-to-one lesson by analyzing student performance in real time. We adapt questions and contents to the individual's level and pace. This is really amazing that this program can do this and can send real-time data back to the teacher to help her or him plan what to do with each student. So we're really individualizing things here. And what does MathSpace align with? With the Common Core best practices of mathematics and differentiation. This is very important. This is a very important one for differentiation. These are some of the things it helps with. It gives students a greater role in improving their understanding. Students feel more empowered. Provides teacher with real-time student performance data. It puts the focus back on learning for engagement, meaning, and personal growth. Because students are not competing against each other. They're not competing for a certain score. They are just competing against themselves. They're learning to grow. They're reviewing things that they need to review, and they're questioning what they're doing and what they need to do next. So the 3 programs we have, these are 3 of, there are many apps and programs you can use to differentiate lessons and follow other best practices in mathematics. These are just 3 of them. Remember, they're GeoGebra, realworldmath.org, and MathSpace. All of these 3 programs can help with the students navigating how to use math in ways other than writing with a pencil and a piece of paper, and opening the students' eyes to how to use technology and how to use the computer is very important, because in the mathematical world, students who want to pursue careers in engineering, etc., all of these skills that they use will be used on computers, because that's what we're using, and that's what the future is. So technology is very important. So I strongly encourage you to use GeoGebra, Real World Math, and MathSpace, and any other things that you can find online to help encourage the students to use technology, to learn the technology, and to be comfortable and familiar with using technology. This is a list of references that I used for this slide presentation today. And that is the end of our presentation. Thank you so much for attending. I hope you enjoyed the presentation. Have a good day.